This is Factoring Easy Trinomials Part 2. I'm changing my riddle here. Name two numbers that multiply to 40 that subtract and give you 3. So think about your factors of 40, what multiplies to give you 40, that when you subtract those numbers, you get 3. Hopefully you thought about 8 and 5. I'm not worried about 3 or negative 3. We're going to fix the sign situation in a second. Name two numbers that multiply to give you 12, that when you subtract them, you get 4. Well, hopefully you think 6 and 2, because 6 times 2 is 12, and 6 minus 2 is 4. Can you name two numbers that multiply to give you 18, that when you subtract them, you get 7? What are your factors of 18? Think about those, and see which ones, when you subtract them, give you 7, and you should have come up with 9 and 2. All right, let's do like we did a minute ago and FOIL this out. This will be x squared plus 2x minus 9x minus 18. When I put these together, this is 2x minus 9x, because these signs are different. When you're dealing with different signs, you take the sign of the larger and subtract. Minus 18. So now pretend we hadn't done that multiplying. Here's x squared minus 7x minus 18 that I want to factor. Well, go to your parentheses. Of course, we know what the answer is. We just did the multiplying. But let's make this come out right. Xx. Follow my rule and bring that minus sign down automatically. Now we look at that negative right there. When that last sign is negative, that tells you that your signs are different. If you've already placed a minus in this parenthesis, then automatically this will have to be a plus. Now let's think about the real math of it. Go back to the multiplying. Why did I get negative 18? Because I was doing a negative times a positive. The only way you get a negative at the end is if you are multiplying different signs. And this little configuration will work for us sign-wise. Now we have to come up with what multiplies to give us 18 that subtracts to give us 7. Why subtract? Well, because the signs are different. Different signs, difference. Here's the neat thing about always putting your middle sign in the front parenthesis. When you have these different signs like this, you are always going to put your bigger factor in the front parentheses. So once you decide it's 9 and 2, you put your bigger factor in the front parentheses. A common mistake is for people to do x plus 9 times x minus 2. But that's going to give us the wrong middle sign. So that's why this little rule is very nice. That minus in the middle, you bring it down to the first parentheses, and then your bigger number gets to go in the first parenthesis. Didn't matter for us on the last several ones because those were same signs. So let's do a couple more. Xx. I look at that sign right there. I bring it right on down. Because the last sign is negative, I know that the signs are different. Therefore, since that's already a negative, that has to be a positive. And then I'm saying what multiplies together to give me 8 that subtracts, because those signs are different, subtracts to give me 2 will be 4 and 2, but I need to put the bigger number in the front. And if you FOIL that out, you can check and see that it really does give you x squared minus 2x minus 8. Xx, middle sign's negative, automatically in the front. Last sign is negative, tells me the signs are different. Therefore, that's got to be a plus. And I'm saying what multiplies to give me 12 that subtracts to give me 11 would be 12 and 1, with the 12 going in the front because we're putting the bigger one in the front. You can only follow that rule of putting the bigger one in the front parenthesis if you always put the middle sign in the front parenthesis. Otherwise, that's not going to work all the time. One thing I would suggest on this kind of problem, when there is no coefficient here, I would pencil in a little number for that. You know that that's a 1x, so that when you set this up, that middle sign is positive this time, so I bring this down. But since the last sign is negative, I know the signs are different. So since I've already placed a positive in the first parenthesis, I put a minus here. And I'm saying what multiplies to give me 12 that subtracts to give me 1, not subtracts to give me x, subtracts to give me 1, would be 4 and 3. Notice I put the bigger factor in the front parenthesis. Xx, middle sign automatically here. Last sign is negative, so I know my signs are different. And then it's what multiplies to give me 28 that will subtract to give me 12. And the only thing that's going to work there will be 14 and 2. So here's your rule. If the last sign is negative, the signs are different. The larger factor takes the middle sign, and by always putting the middle sign in the first parentheses and then placing the larger number in the first parentheses, we're making that happen. And what you say to yourself is what multiplies to equal the last number that subtracts to equal the middle number because of this different signs difference idea. So a couple more examples. X and X will go in the front. What do you think the sign is going to be in the very first parentheses? Hope you said plus because that sign comes down. What's the sign in the next parentheses? Hope you're thinking minus. And then it's what multiplies to give us 14 that subtracts to give us 5 would be 7 and 2. XX. Sign is negative, so we're back to a minus in the front parenthesis. Since the last sign is negative, I know the signs are different. That would have to be plus. And what multiplies to give me 32 that subtracts, because those signs are different, different signs, difference, would have to be 8 and 4. Okay, parentheses, X, X. Sign is positive, so I'm coming down. Last sign is negative. That will have to be a minus, and I'm saying what multiplies together to give me 4 that subtracts to give me 2, and looks like I'm in trouble because what multiplies to give me 4 is 4 and 1. That doesn't subtract and give me 2. Or 2 times 2 gives me 4, but that doesn't subtract and give me 2. Since the only possible candidates do not work, that says this thing is unfactorable, and what we call it is prime. If the polynomial cannot be factored, we call it prime. Now, to make the problem a little more complicated, sometimes there is a GCF. You've already learned about taking out the greatest common factor. The greatest common factor needs to be the first step in every factoring problem. Does every problem have a common factor? No, but if it has one and you don't find it, it's going to be wrong. So first step, look for a GCF. And then the GCF has to be included in your answer. So look here, common factor is 2. So if I divide all of those by 2, and remember from the GCF lesson, you could put a little 2 underneath there to help you out with your division. Gives us x squared minus 3x minus 4. So we're looking at this trinomial that has an x squared left in it. That says, hey, there's a pretty good chance that this little trinomial keeps on factoring. So I'm going to assume it does. Be sure you bring your GCF down as part of your answer. And then treat this just like we did a minute ago. We have an x in the front. Middle sign is negative. Last sign is negative, which tells me the signs are different. And then I'm saying what multiplies to give me 4, which subtracts to give me 3, will be 4 and 1. And that's my whole answer, including the GCF. Do not drop the GCF out of your answer. The reason we need the GCF is that this and this are equal. They're just dressed up differently. This is the factored form. This is the expanded form. If you don't have this 2 in front here, when you multiply this together, you're not going to get that polynomial. You look at this problem and you think, hey, there's no common factor at all. But remember the GCF lesson. If there is a negative in front of the x squared, we want to factor out that negative. You could pretend there's a little 1 here if you want, and you want to factor out a negative 1, which turns us into x squared plus 8x plus 15. And the reason we want to do this is that our sign rules do not work properly if that's a negative x squared. That's why we factor out the negative so that we can use our sign rules that we just learned. So XX, that's a middle sign of a positive, automatically bring it down. I look at the last sign as positive, which tells me that the signs are the same, so that's a plus. And because the signs are the same, I'm saying to myself, what multiplies to equal 15 that adds to give me 8 would be 5 and 3. And this, including the negative 1, will be your complete answer. Now, you could just get away with a negative in front of the parentheses. That would be acceptable. But there's nothing wrong with typing in, when you're talking about my math lab, a negative 1 right there. So either one of those would be acceptable answers. Sometimes your GCF is a variable. Notice there's no number that goes into all of this, but there is an x everywhere. So if I take out a GCF of x, and this is where you might want to draw in that x to help you do that canceling correctly, gives us x squared minus 5x minus 6. Bring your GCF down. I look at that being x squared, and I'm thinking, yep, there's a pretty good chance that keeps on factoring, so I'm going to pretend it does and see what happens. So xx, sign situation, because that's a negative, we're bringing that on down. Because the last sign is negative, that tells me the signs are different. So since that's already a negative, that has to be a positive. And I'm saying what multiplies to give me 6, that subtracts to give me 5. Subtract because these signs are different. And that would be 6 in the front and 1 in the back. And this is your whole answer. The GCF times those two binomials. All right, let's look at one more. A GCF here of 2. This is x squared minus 4x minus 3. I see that x squared right there, and I think, yep, it probably keeps on factoring. Bring my GCF down. X, that's a negative, so I bring down that sign. Because that's negative, I know my signs are different. And now I'm saying what multiplies to give me 3 that subtracts to give me 4, because those signs are different. What multiplies to 3 that subtracts to give you 4? Well, there's nothing. Now, be careful. Just because the polynomial right there doesn't factor further, do not call that prime. Prime says it could not be factored at all. Well, we factored it. We factored out a GCF of 2. It just so happens that the polynomial didn't go any further. So that is my answer. Do not write prime here. It's not prime. We factored it.